Okay, how you guys doing there? Hopefully you're doing okay. We're getting ready to start section 3-2. Just so you guys know, this assignment's not going to be due until I think the 17th. That's next Tuesday, Tuesday the 17th of November. I think this section's not going to be that bad. I think it's a new concept we've never talked about, but I think it's a pretty straightforward section. There's a few kind of questions that are kind of tough, but I think you'll do okay with it. What we're going to do is this. Before we actually start section 3-2, we're going to actually backtrack a little bit. We're going to try to put yourself in a mindset of a third grader, okay? Literally a third grader, okay? If I was to give a third grader this question, you guys did questions like this. You did algebra back in third grade, whether you realize it or not. If I was to give you this question, 2 times box equals 8, okay? That's an algebra problem. It's just we use x's and y's instead of boxes and triangles and circles and stuff like that. You know, you did a worksheet like that back in third grade. You'd say, oh, that's 4. You know, 2 times 4 is 8. You fill in the little box with 4. Or if I give you 3 times triangle equals 15, you'd go, oh, yeah, you got to put a 5 in the triangle. 3 times 5 is 15. Well, think about a third grader, okay? What if they gave you this? 2 times box equals 7, okay? What's a third grader going to say? Now, don't say, oh, they're going to say 3.5 or 3.5. No, they're not, okay? They're going to say, you can't do that. You can't multiply 2 by something to get 7. You can't do that, okay? Well, yes, you can. They just don't understand what fractions and decimals are yet, okay? So that does have an answer, but they don't understand it yet, okay? Now, just because they don't understand fractions and decimals, does that mean they don't exist? No, they just don't understand about them yet, okay? So why do I bring that up? Well, because when you were, first started school back in kindergarten, first grade, and so forth, the numbers were 1, 2, 3, 4, 5, and so forth. Then you eventually started learning about fractions and decimals. You eventually started learning about negative numbers. Like, for example, if they did 2 minus 9, a third grader or second grader would say, you can't do 2 minus 9, you can't do that, okay? But now we understand that there are negative numbers, and yes, you can do that, okay? So, why I bring that up is this. If I was to give you this problem right here, x squared equals negative 9. X squared equals negative 9. Now, I think we briefly mentioned this once a few days back, but I just want to make sure we understand. It's a second degree, so there's going to be 2 answers, okay? If it was third degree, there'd be 3 answers. If it was fifth degree, there'd be 5 answers, okay? So there's supposed to be 2 answers here, okay? So we ask ourselves, what number can we square and get negative 9? Well, you might be tempted to say negative 3. Well, when you square a number, you times it by itself. If I take negative 3 and times it by itself, negative 3 times negative 3, we get a positive 9. I want a negative 9. Is the answer positive 3? Well, positive 3 times positive 3 is also positive 9. Now, you may be going, well, what if I times 3 times negative 3? That gets you negative 9. Yeah, but 3 and negative 3 are not the same number. When you square a number, you times it by itself, okay? So, does this have any solution, let alone 2 solutions? It's supposed to have 2 solutions. The answer is yes, okay? But there's something called imaginary numbers. Now, just so you understand, okay, just like fractions and decimals and negative numbers, okay, they exist just like in random numbers like 1, 2, 3, 4, 5, okay? I hate the word imaginary because students tend to think, those don't count. Those don't really count. Yes, they do, okay? Imaginary numbers do exist. They're just not real. Sounds like a contradiction, but that is the case, okay? So we need to introduce imaginary numbers to you, okay? In this section, section 3.2 is called complex numbers. What you need to understand is every number you've ever dealt with so far, in every math class you've ever had, has been a real number. Small numbers, big numbers, positives, negatives, 0, fractions, decimals, nice round numbers, everything. Every number you've ever dealt with has been a real number, okay? We're going to introduce imaginary numbers. And if you take the real numbers plus the imaginary numbers, you put them all together, that's what are called complex numbers, okay? So we're going to introduce. Well, like if I was to introduce, say, what is there a number between 2 and 3? Well, yeah, 2.5, 2.1, 2.7, 2.386. There's a whole bunch of numbers between 2 and 3. But if there wasn't such a thing as decimals, there would be no number that would go between them, okay? 3 comes right after 2, but we introduce the decimals. So, and you guys are okay with that. You understand decimals exist. You work with them now. So, same with imaginary numbers. Just get it out of your head right from the beginning. Don't be thinking, they don't really count. They're imaginary. Yes, they do. That's what this entire section's about. So, what you need to understand is, this is the lowercase I. That stands for an imaginary number, okay? And the imaginary number is the square root of negative 1. This is a number, the number I, and I is the square root of negative 1. If you type in the square root of -1 in a calculator, it's going to say error because your calculator only deals with real numbers, okay? But this right here, think about a square root of a negative. You can't normally do that, okay? Like if I ask you the square root of -25, what do you times by itself to get -25? You can't do that with real numbers. It's not -5 because -5 times -5 is positive 25. It's not positive 5 because 5 times 5 is positive 25. Again, you might be thinking, well, -5 times positive 5 will get you that, but that's not the same number. You got to times a number by itself. So that's why we have to introduce this new number, just like numbers between 2 and 3, like 2.5, okay? This is the square root of -1. That's the number I. You might also want to jot down this, I squared. If I square this, I also have to square this, and these symbols cancel each other off, okay? So I squared is, if they cancel off, just -1. If I is radical -1, I squared is -1, okay? So you're gonna wanna use that. This is information you've gotta know for this section, okay? New number, it's an imaginary number, okay? So let's look at section 3-2. We're gonna start on question, what's 3? Question number 5. Okay, so here's what you're gonna do. It says, find out what radical -36 is. Radical -36. So here's what we're going to do, all right? And I'm going to do it this way, and then later on I'll alter it to make it a little bit easier, okay? That is the same as radical -1 times radical 36, because -1 times 36 is -36, okay? Well, what is radical -1? Well, we just said back here it was I. So I times radical 36 is 6. And I times 6 is 6i. And that's the answer, 6i. And it works because if I take 6i and times it by itself, 6i times 6i is 36i squared. And what is I squared? I squared is -1. -1 times 36, there we go. Okay? So the answer is 6i. Okay? Let's look at question number 7. Okay, number 7, we have radical -18. Basically, what you need to understand is this. Whenever you see, this is huge right here, whenever you see a negative inside of a radical, it's imaginary, okay? If this negative had been outside the radical, it's not imaginary. Radical 36 is 6, that would make it -6, okay? So whenever there's a negative inside of a radical, it's an imaginary number, okay? So here's what we're gonna do. We can break this up into radical -1 times radical 18. Now, if you type in the square root of 18 on a calculator, you're going to get a decimal. That's not what I want. I'm going to give you a list of numbers that we're going to use a lot this year, okay? The list of numbers is 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. I'll go 121, 144, 169, 196, and 225. I don't want you to memorize that list. I want you to understand where it comes up from, okay? These are the first 15 square numbers, okay? If it was me, I would probably write this like on the back of a folder or something like that because you're going to use this list a lot, okay? But I want you to understand how to come up with this list. The first square number is 1 because it's 1 times 1, 1 squared. Second number is 2 times 2, 2 squared. 3 times 3, 4 times 4. The 15th number on the list is 15 squared, 15 times 15. If I asked you for the 48th number on the list, it'd be whatever 48 times 48 is. I don't know what it is. I don't really care what it is, okay? But I want you to understand that the 48th number on the list is 48 times 48, for example. 37th number would be 37 times 37, whatever that is, okay? So 18 is not on this list, but there is a number that goes into 18 on this list. And you might be saying, well, 1 does. Don't ever pick 1. 1 goes into everything. 1 is a waste of time because 1 works for everything. 9 goes into it. So we have radical -1, radical 9 times radical 2. Radical -1 is I. Radical 9 is 3. Radical 2. And we don't say I3, we say 3I. Radical 2. And the reason why it's imaginary is because there's a negative inside the radical. Number 9. Okay, question number 9. We have 2 radical -16. Well, negative radical 16, we could say radical -1 times radical 16. Okay, so 2 times radical -1 is I, radical 16 is 4, because 4 times 4 is 16. And then 2 times I times 4, we could say 8I. And it was definitely imaginary because there was a negative inside the radical. Okay, number 11. Negative 4, radical negative 32. Well, we could break up negative 32 into negative 1 times 32. Now 32 is not on the list. Now we go, well, 4 goes into 32, and it does. But if you can find something bigger that goes into it, that's even better. 16 actually goes into 32. So negative 4, radical negative 1, radical 16, twice. So negative 4 times radical negative 1 is I, radical 16 is 4, radical 2. And I'm allowed to times 4 and negative 4, but I can't times 4 and 2 because that's in a radical and that isn't. But since neither one of these are in radicals, negative 4 times 4 is negative 16I, radical 2. Okay? All right. Let's get number, what's next, 13? Okay, a lot of questions in these because these things are fairly quick questions once you understand how to do them. So number 13, it says 4x plus 2i equals, okay, 4x plus 2i equals 8 plus yi. This looks kind of hard. It's not. So what you need to understand is, these are, if I gave you, these are just imaginary numbers, but complex numbers are of the form a plus bi. A is probably, for example, 4 plus 2i. That's a complex number. It has a real part and has an imaginary part. That's imaginary simply because it's got an I. That's real because it doesn't have an I. That's simple, okay? It doesn't have to be plus. It could be 7 minus 3i. It could be negative 8 plus 9i. But it's got to have a real part and an imaginary part. So all they want you to do here is to find out what x and y have to be in order to be a true statement. So what we do is, I'm going to underline the real part. That's real because there's no I. That's imaginary. That's real. There's no I. That's imaginary. So this has to equal this. So 4x has to equal 8. Divide by 4, x has to be 2. Then set the imaginary parts equal to each other, okay? 2i has to equal yi. Well, I mean, what does y have to be? It just has to be 2. I mean, 2i has to equal 2i, so y has to equal 2. So if x was 2 and y was 2, then that would be a true statement. That's all they're asking you to do. Well, it makes a true statement. Okay? 15, same type question. Negative 10x plus 12i. 12i has to equal what? 20 plus 3yi. 20 plus 3yi. Okay? So, I'm just going to do these in my head because I think you should be able to do these in your head. These are the real parts because there's no I. What do I times negative 10 by to make positive 20? Negative 2. If you want to write it out, you can, but I mean, that should be one you can pretty much do in your head, I would think. And then the same thing here. 12i has to equal 3yi, okay? Well, 3 times what would give you 12? 3 times 4. If I plug in 4, 3 times 4 is 12. 12i equals 12i. Okay? All right. Now, number 17, just a few more of these type of questions. So 17, we have what? 2x minus yi equals something. 14 plus 12i. 14 plus 12i. Okay, so the real parts, 2x has to equal 14. Again, that's real because there's no i's. X has to be 7. 2 times 7 has to equal 14. Okay? And then this has to equal this. So negative yi has to equal 12i. So what would I have to plug in for y to make 12? Y would have to equal negative 12 because negative 12 gives you positive 12. So as long as x is 7 and y is negative 12, we're good. Okay. So that was number 17 and number 18. Okay, number 21. Okay, let's get into some easier questions, okay? So I don't know why, but every now and then students tend to struggle. It seems like every year they struggle with that type of question. If you're struggling, you might want to back up the video, watch it again, that part. I think this next part, though, is really, really, really simple. It's not number 19. It's question number 21. Okay? So now we're adding complex numbers, okay? So on number 21, we have 6 minus I plus something. 7 plus 3i. 7 plus 3i. Okay? All you do is this. You add the real parts, you add the imaginary parts, you're done. So the real part's 6, the real part's 7, 6 plus 7 is 13. Negative I and positive 3i, that's a negative 1i, and a positive 3i is 2i. That's done. That's all. You're all done. You're just adding the real parts and the imaginary parts, and that's it. Okay, when we subtract them, you do it, oh, we're doing them right now. Now we're subtracting them. So we have 12 plus 4i minus, okay, minus what? 3 minus 7i. I would do this. Here's what I would do, okay? I would distribute this negative sign, okay? So we have 12 plus 4i. At 3, when I distribute, it's going to turn into negative 3. And negative 7 is positive 7i. And then just combine like terms, okay? When I say like terms, the real parts combine and the imaginary parts, we combine those, okay? So we add 12 and negative 3, and that's 9. 4i and 7i is 11i. 25. Now we're back to adding again. 12 minus 3i plus something. What? 7 plus 3i. 7 plus 3i. Okay, so I'm not going to show any work on this. We can put together 12 and 7. That's 19. We put together imaginary parts, negative 3i and positive 3i. They cancel. So do I put 0i? The computer will probably mark you wrong, okay? I wouldn't mark you wrong on a written test, but I would just put 19, okay? Again, you might put, if you put 19 plus 0i, very likely the computer's going to say no. Okay? All right, number 27. Number 27. They're asking us to add or subtract. Okay? Now, if you're wondering, are we ever going to multiply these? Yes, we will, coming up soon. So on 27, we have 7 minus 3 plus 4i. Then what? Plus 6i. So here's what I would do. I would distribute this negative sign, so just drop down the 7. 3 becomes negative 3. 4i becomes negative 4i plus 6i. Put together the real parts, 7 and negative 3, that's 4. Put together negative 4i, the imaginary parts, and positive 6i, and that's a positive 2i. And don't put those together and make 6i. You can't do that, okay? You can't add the real and the imaginary together and make one term out of them, okay? 29. We have what? Negative 10 plus 6 minus 6 minus something. 5i minus 9i. Okay, so if I distribute the plus sign, we're just going to have plus 6 and minus 5i. When you distribute a negative sign, they change. When you distribute a plus sign, nothing changes. So put together 10 and negative 6. I'm sorry, negative 10 and positive 6, that's a negative 4. Put together the imaginary parts, negative 5 and negative 9 is negative 14i. Okay, then number 30, then we're going to skip, we jump ahead to number 37. Number 37, okay? Now we're going to start multiplying imaginary numbers and complex numbers, okay? So we have 3i, negative 5 plus I. 3i, negative 5 plus I. I think that's what it says. 3i, negative 5 plus I. So we're going to distribute 3i. Now you can multiply them. We said we can't add these and make 6i out of them, but you could always multiply complex and imaginary numbers, okay, or real and imaginary numbers. So 3i times negative 5 is just negative 15i. And 3i times I is 3i squared. Don't forget to put the square, okay? I times I is I squared. Now we're not done. I told you at the very beginning, I was the square root of negative 1, and I squared is negative 1. Well, I squared is negative 1, so negative 15i plus 3 times negative 1. 3 times negative 1 is negative 3. Now, if you type this in, the computer might mark you wrong. And I would probably mark you wrong because complex numbers have to have the real part first. Real, imaginary, real, imaginary, real, imaginary. So I should put the real part, negative 3, first, then negative 15i. That's just the way it's always written. You always are supposed to put the real part first. Okay? The computer may or may not mark you wrong, but it should mark you wrong because that's just the way it's done. Okay? 37, let's move on to number 39. Okay, so now we're going to do some foiling. Okay, foiling. So we have 3 minus 2i, then 4. 4 what? 4 plus i? Yep, 4 plus I. Okay, so we're going to FOIL this out. Our first terms are 3 and 4. That's 12. Our outers is 3 and 1. That looks terrible. It's not getting any better. 3 and I is 3i. My inners are 4 times, watch your negative, negative 2i. That's a negative 8i. And then our last, if these were our first, our last have to be negative 2i and a positive I, which is a negative 2i squared. Remember, when you FOIL, you're multiplying. You're multiplying your firsts, your outers, your inners, and your lasts. Okay? Now, we're not done. I can put these two together. So we have 12. 3 and negative 8 is negative 5i. Minus 2 and I squared is negative 1. Okay? So we could put times negative 2 and negative 1, and that's a positive 2. And then we can still put together 12 and 2 and get 14 minus 5i. And that's what you want first. Your real part first, then your imaginary part. 41. Okay, where's 41 at? Okay, so we have 4 minus 2i, 4 plus 2i. 4 minus 2i, 4 plus 2i. Now, there's a shortcut to doing this problem, but I'm not going to show it to you right now. I'll show you that in a few sections, okay? We're just going to FOIL this thing out. Okay, our first terms are 4 and 4, that's 16. Our outers are 4 times 2i, that's 8i. My inners are 4 and negative 2i. 4 times negative 2i is negative 8i. And my last are negative 2i and positive 2i. Be careful, some students say, oh, those cancel. They cancel if you're adding. We're multiplying. Negative 2i times positive 2i is negative 4i squared. Now these cancel. 8i and negative 8i cancel. So we're left with 16 minus 4, I squared is negative 1. We times negative 4 and negative 1, and that's a positive 4. 16 and 4 is 20. How about that? We times a couple of imaginary numbers, and ended up with a real number. That can happen, okay? That definitely can happen. All right, next one. Okay, that was 41. 42, on to number 43. Number 43. Getting closer to being done with this section. Okay, so we have 3 minus 6i squared. 3 minus 6i. Okay, so when you square something, that means you times it by itself. So 3 minus 6i times 3 minus 6i. And then we FOIL. First are 3 and 3, that's 9. Outers are 3 times negative 6i, that's negative 18i. My inners are also 3 times negative 6i, which is also negative 18i. And my lasts are negative 6i times negative 6i. A negative times a negative is a positive. 6 times 6 is 36i squared. Negative 18 and negative 18i is a negative 36i's. I squared is negative 1. So 36 times negative 1. So we have 9 minus 36i. 36 times negative 1 is negative 36. We can put together 9 and negative 36. That's negative 27 minus 36i. Okay. Okay, on to number 49. Now, why are we doing this? I mean, we're thinking, big deal, imaginary numbers, who cares, okay? Because it helps you find solutions. Again, if I gave you the question I showed you at the very beginning, 2 times box, or whatever that is, equals 11, if decimals and fractions didn't exist, that would have no solution. It wouldn't have any solution whatsoever. But we know that there are decimals and fractions, so there's a solution to that, okay? So when you look at number 49, 49, it says x squared plus 9 equals 0. X squared plus 9 equals 0, okay? We're supposed to have 2 answers, okay? So let's find them, okay? We learned in the last section, if we only have one x, we can solve the square roots. So let's do that. What's minus 9? Minus 9. X squared equals 0 minus 9 is negative 9. Then we have to square root. And remember, when you square root, you got to put the plus or minus symbol there. These cancel, we're left with x. Now, radical negative 9, okay? Well, that's the same as radical negative 1 times radical 9. Radical negative 1 is I. Radical 9 is 3. So we're left with I times 3, which is 3i. Now we're supposed to have 2 answers. Where's the other answer coming from? Don't forget the plus or minus. So it's plus or minus 3i. That's 2 answers. 3i and negative 3i, okay? And we're supposed to have 2 answers, and we got them. So if imaginary numbers didn't exist, that wouldn't have any answers. But we know that they do exist now. So there are 2 answers, 3i and negative 3i. Okay, on to number 51. 51, we have what? X squared minus 4 is negative 11. X squared minus 4. Okay, so we add 4 to each side. We can do that. We can square root this one because there's only one x. So we have x squared equals negative 11 plus 4 is a negative 7. And then we square root. Make sure we put the plus or minus symbol. So x equals That's the same as radical negative 1 times radical 7. Now, the square root of 7, I still have it? 7's not on the list, but what goes into 7? Only 1, and we said don't use 1. So how do you simplify radical 7? You don't. And be careful, some students say, well, it's 3.5. No, it's not. 3.5 times 3.5 is not 7. Okay? So this is just I radical 7, and don't forget the plus or minus. So your answers are I radical 7 and negative I radical 7. 53. Okay, so we have 2x squared plus 6. 2x squared plus 6 equals negative 34, I think it is, negative 34. Okay. So again, we're supposed to have two answers. It's second degree, we're supposed to have two answers. Let's find them. We can use square roots, so let's minus 6 to each side. 2x squared equals negative 34 minus 6 more is negative 40. We divide by 2, divide by 2. X squared is negative 40 divided by 2, which is negative 20. Okay. Then we square root. Make sure we put the plus or minus symbol there. Negative 20 is the same as negative 1 times 20. And 20 is not on the list, but there is a number on the list that goes into 20, 4. So radical negative 1, radical 4, radical 5. Radical negative 1 is I, radical 4 is 2, radical 5. I times 2 is 2I, radical 5, and don't forget the plus or minus symbol. So the two answers are 2I radical 5 and negative 2I radical 5. Three more to go, I think. Okay, find the zeros. Okay, find the zeros of this. If you remember from the previous section, okay, we have f of x equals 3x squared plus 6. I think that's what it says. Yep, okay, the zeros, we set it equal to 0. So 0 equals 3x squared plus 6. Again, we should have two zeros here because it's to the power of 2. We should have two answers. So we subtract 6. We can do that. We're square rooting because we only have one x. 0 minus 6 is negative 6. And then we divide by 3. Divide by 3. 6 over 3 is negative 2. Is x squared. We square root it. Don't forget the plus or minus symbol. Negative 2 is negative 1 times 2. 2 is not on the list, and nothing goes into 2 besides 1, so we're not going to do anything with that. Be careful. Some students think the square root of 2 is 1. It's not, because 1 times 1 is not 2. So we have I radical 2. Don't forget the plus or minus symbol. So the two answers are I radical 2 and negative I radical 2. Two more, 57, I think. Yep, 57. So again, we have the zeros. It says h of x equals what? 2x squared plus 72. Okay, so we set it equal to 0 to find the zeros. 2x squared plus 72. Now, if you're not looking at the assignment, you're going, well, why are we finding the zeros? Because that's what the instructions say, okay? It says find the zeros, okay? So we subtract 72, 0 minus 72 is negative 72 equals 2x squared. Divide by 2, divide by 2. 72 divided by 2 is negative 36 equals x squared. And then we square root it. Plus or minus. We make that negative 1 times 36. Well, negative 1 is I, square root of negative 1 is I, and radical 36 is 6. So the answer is 6I, but plus or minus. 6I as well as negative 6I. Last question, 59. Okay, so we have m of x equals negative x squared minus 27, I think it says, minus 27. Okay, so we set it equal to 0. 0 is negative x squared minus 27. Okay, and then I'm going to add 27 each side. So 0 and 27 equals negative x squared. Before I square root it though, I want to have the x all by itself. So I need to think of that's negative 1, divide negative 1, divide negative 1. So you have negative 27 equals x squared. We square root, plus or minus symbol. We break that down into negative 1 times 27. 27 is not on the list, but 9 is on the list, and it goes into it. So square root of negative 1, square root of 9, square root of 3. Square root of negative 1 is I, times square root of 9 is 3, times radical 3. I times 3 is 3I, radical 3. And don't forget the plus or minus symbol. So the two answers are 3I radical 3 and negative 3I radical 3. Okay? Questions on this? Why am I asking that? There's nobody here. That was stupid. Hopefully I got a laugh out of you there. Anyhow, if you do have questions though, just make sure you email me and I'll get back in touch with you, and just hope to see you guys soon. And again, this is due, when did I say it was due? The 17th, sorry. 17th of next Tuesday, the 17th of November.